We are wrapping up the U-tries for our equations topic with lesson 7, using formulas. We know that this is not everybody's favorite lesson. It is a little bit tricky. So if you do need some extra help with those 6 problems I left you to practice to ensure you got the skill down, please feel free to check out this video, fast forward to a problem you got stuck on, and hopefully your questions will be answered. You're doing a great job, and let's get right to it. So for number 1, it asks us to isolate y. So I'm going to try to see if I can just do a little highlight on that y. And so we need to use all of the skills we learned for solving equations to get that y by itself. So I'm going to still, I'm going to still draw my line down the equal sign. And I need to get, so for right now, I'm going to put the 3y in the box because I want to isolate y. So how I'm going to move over that 2x is I'm going to subtract it, okay? Bring down my 3y. Now, here's where we have to pay attention. We have 9 minus 2x. Those are not like terms, so we're going to write each of them. It would not be wrong if you wrote negative 2x plus 9, okay? Then from there, we need to get y by itself. So the opposite of multiplying by 3 would be to divide by 3. But unlike what we've seen with just plain old solving equations is we have 2 terms on that right-hand side. And both of them need to be divided by 3. So that's going to leave us with y equals, now you can write it and leave it as one fraction, or we can separate it into 2 fractions. And from there, we can say, oh, well, we know what 9 over 3 simplifies to. That just simplifies to 3. And then this is going to be 2/3 x. Or you can write it as 2x over 3, whichever you prefer. It would not be wrong if someone wrote their answer as negative 2/3 x plus 3. In fact, if you look at the answer key, I'll have all the variations of solutions that you can have written down that would be acceptable. You may just have to ask your teacher what they prefer. Sometimes we prefer to have that variable first in our standard form. Sometimes we prefer it to be one term, so leaving it as a single term, not splitting up that fraction for both values there. So you just have to see what they are wanting for you. Okay. Number 2, we're going to solve the equation for w. So here I'm going to draw my sign down the equal sign. I'm going to put my w over 5 in the box. How I'm going to get that box by itself is I'm going to add 2 to both sides. Z plus 2 will stay z plus 2. They are not like terms, so I will keep them separate. And now last but not least, how do I get rid of dividing w by 5 is I multiply it by 5. And now here's the thing, because I have 2 terms on that right-hand side, that becomes a quantity. So you want to make sure you put parentheses around that. So that's going to give us w equals z plus 2 and then times 5. And you could put that 5 in the front or in the back, but what's important is that there's no sign in between the parentheses and the 5. And now your teacher will probably want you, or to simplify it further, you'll just have to check with them. So to distribute that 5. So that's going to give us 5z plus 10. It may depend on the context of the problem. So that's how we would isolate w there. You'd get the same answer as 10 plus 5z, right? They're all equivalent expressions. Okay, so moving right along to number 3, they want us to solve for m in this problem. Now, before you get started and you say, oh, the 3 m's on the left, make sure you take a look. There is an m on the left and on the right. So we need to condense that to one singular m. Okay, now there is a way you can go about this where we're going to work smarter, not harder. So because that 10m only has one term on that right-hand side, I'm going to bring all my m's over to that right-hand side. A little bit different than what I normally do, right? So if you brought the 10m over to the left, you would subtract it. And when you go to subtract it, that right-hand side would leave you with 0. So if you go to check the answer key, I will leave the alternative way to go about it if you're in the habit of moving things to the left first, okay? But to move that 3m over, we're going to subtract 3m. This is going to give us a little less steps to do, leaving us with negative k. 10 minus 3 is 7m. And now from there, we just have to get m by itself, and it's currently being multiplied by 7. So the opposite of multiplying by 7 is to just divide by 7. And so that's going to leave us with negative k over 7 equals m. And as stated in the key, I will write all the other ways you can write this equivalent. As you might write it as negative 1/7 k, that's the same exact answer. Okay. Looking at number 4, we need to isolate that g in that numerator. Okay, so how we're going to do this is I'm going to first, draw my line and put my g in the box. First, I need to break free of that fraction, that division of 3. So the opposite of dividing by 3, we know, is to multiply by 3. And when I multiply both sides by 3, I'm not thinking, oh, distribute that 3 on the left. That 3 will cancel with the 3 in the denominator. So that's just going to wipe me clear of my fraction, leaving me with h plus g. Then on that right-hand side, k times 3, we like to write the coefficient first, is going to leave us with 3k. And now last but not least, we need to get g by itself. So to move that h over, we're going to subtract it. Okay, bring our arrow for g. 3k and h and negative h, they are not like terms, so we cannot combine them and write them as a single thing. So we're going to keep them separate as 2 terms. And that will be our answer. It would not be wrong if you have negative h plus 3k. All right, the last 2. So for number 5, they want us to isolate h. This is the volume formula for a rectangular prism or whatever you might have. It's length times width times height. And so if we wanted to isolate and solve for the height, that's saying we are currently multiplying by L and W, and we can get rid of that all in one. The opposite of multiplying by L is to divide by L. The opposite of multiplying by W is to divide by W. And we can do that on both sides. I make my L's cursive so they don't look like a 1. And that's going to cancel those L's and cancel that W and leave us just with H. Looks a little bit different having our isolated variable on the right, but that's how we would do that. And finally, our perimeter formula. Perimeter is 2 times the length plus 2 times the width. So if they ask us to solve for just W, we want an equation where it's width equals, right? So we are going to put our 2W in the box. We're going to move over that 2L to the other side by subtracting it. And remember, not like terms. So we're not going to combine them. We're going to keep them separate, and we'll bring that 2W down. Last but not least, we're going to divide both sides by 2. We have 2 terms on that left-hand side, so we need to divide the entire thing by 2, not just one of the terms, but both of them. And from there, you can separate them if you wish. You can write that as P over 2 minus 2L over 2. That's going to equal W, and if you want to condense that a little bit more, we can leave that as p over 2. Negative 2 divided by 2 will give us negative 1, so we can write that as 1 minus 1L or just minus L, because there's like that invisible 1 there, and it will equal W. So that wraps up all of our equations topic. So hopefully you found that helpful. Stick to it. I know this last lesson is a little bit tricky, but if you have those skills for solving equations down pat, you can just treat each of these like an equation, and you're just isolating a variable where not everything's going to combine, where you might have two terms on one side, and that's okay. So keep up the great work, and I look forward to continuing Algebra 1 with you.